So today we're going to be talking how to multiply two binomials. So first let's ask the question, what is a binomial? Well, let's break up the word, right? So we have bi, which means two, and we have nomial, which we can just call term, right? So what do we have here? We have two terms. So if we have something like 2 plus 3, this is a binomial because we have two terms. We have 2 and 3. If we had something like 2x plus 3, this is also a binomial. So our first term is 2x and our second term is 3. But if we have something like, let's say 8x times 8y, this is simply one binomial because it's being separated by a multiplication symbol. So in fact this, right, so let me circle this. So this can be rewritten as, let's just rewrite this over here. So this can be rewritten as 64xy. And so now we're back to one term. But we can make this into a binomial by doing 8x plus 8y. So what makes a term is if it's separated by an addition or subtraction symbol. So if this was, say, minus, this would still be two terms. However, if we had the division symbol, right, this can be rewritten as 8x over 8y. And then once again, we can simplify this to be xy, or x over y, right? So this is equivalent to this, and as we can see, it's just one term. So as long as we have two numbers or variables separated by an addition or subtraction symbol, we have our terms. And in this case, in the case where we're talking about binomials, there is just one addition symbol or one subtraction symbol right in between our numbers or variables. Okay, so let's look at a simple example. Let's practice using just numbers, right? So how do we multiply, say, these two binomials, right? So again, let's recap. So this is one binomial because we have 2 and a 3 separated by a plus sign. So this is one term and this is one term. And then here we have our second binomial where 5 is one term and 6 is our second term. So how do we multiply this out? Well, you may be thinking, well, I would just add whatever's on the inside, right? So 2 plus 3 would give you 5, and then 5 plus 6 is 11. You multiply this out to get 55, right? So in a lot of cases, binomials won't be this simple. In fact, you'll have like a symbol, you'll have variables within it, so you wouldn't be able to just add 5 plus 6y. So we're going to look at how can we multiply binomials in any scenario, whether they're just whole numbers like this or they have variables. So let's keep in mind that when we did evaluate this expression, we got 55. So I'm gonna write the answer up here, and we'll come back to this answer. Okay, so our first step is to write down on the side FOIL, and this is gonna be our key to solving any binomial. Any binomial we have, no matter what it looks like, as long as it has two terms and there's two binomials, we can use FOIL. And what FOIL stands for is first, outer, inner, and last. So what does this mean? What does this acronym mean? Well, it's a set of directions on what should we multiply first. So kind of like how PEMDAS is parentheses, exponents, multiplication, division, addition, and subtraction, FOIL is the same thing. It's like our order of operations when multiplying binomials. So let's start at the top. Let's start with the first letter. FOIL, first, F. So since it says first, we have to multiply the first term of each binomial. So let's look at this binomial, 2 plus 3. The first term is 2. And then if we look at our second binomial, the first term is 5. So let's multiply these two together. Right, so 2 times 5 is 10. And now our second one, so let's cross off our first one. So we did first. Now let's do outer. So what are the outer terms? Well, if we look at the multiplication, we look at 2 plus 3 times 5 plus 6. Our outer is going to be this 2. Let's do another circle. And then 6, right? Because these are at the outside of our expression. They're at the edge of our expression. So what is 2 times 6? Well, 2 times 6 is going to be 12. And anytime you find the product of outer, inner, last, you're going to put a plus symbol. So we found out first, so we wrote down our 10, and then we're going to add on our outer. Now for inner. So our inner terms are going to be 3 and 5 because they are on the inside of the binomials of this whole expression. They are on the inside. So 3 times 5 is going to give us 15. So again, we're going to add. And then our last, right, are going to be our last terms, and it's going to be the last term in this binomial, which is 3, right? 2 plus 3. This is going to be our second term, our last term. And then we have 6 over here, and 6 is also going to be our last term because we have 5 plus 6, and it comes second. So 3 times 6 is going to give you 18. Great. So when we add all this up, so 10 plus 12 is 22, plus 15 is going to give you 37, and then finally plus 18 is going to give us 55. And as you can see, it's the same exact answer as if we just did 2 plus 3, 2 plus 3 equals 5, and then 5 plus 6 equals 11. Multiply those together is 55. So we see that our two answers are correct. And this is an important thing to note because this proves that the FOIL method works, right? Because if we got a separate answer, say if this was like something like 60, right? We know that FOIL wouldn't work. We know that FOIL wouldn't be a valid method because when we solve it, just adding our numbers on the inside and then multiplying together, then we know that it just wouldn't work. So now let's try another example where we have variables. So let's try something like 4x plus 2 times, let's say, x plus, actually, let's do something a little simpler. So let's do x plus 2 and then x plus 3. So, all right. So again, we're going to write down FOIL on the side. Write out our acronym, or we don't have to, but just so we at least have a reminder what each letter stands for. Okay, so our first step is to multiply the first term in each binomial. So in this case, it'll be x and x. Well, what is x times x? What is any number times itself? Well, it is the number squared. So x times x, we can just leave that as x squared. So we have our first step done. Now, outer. So we need to take the outer terms of this whole expression. So x times 3. So x times 3, well, we don't know what x is, so we can just leave this as 3x. Great. And now inner. So our inner terms are going to be 2 and x. So 2 times x is going to give you 2x. And finally, our last. So we got to multiply the last term. So 2 and 3. So 2 times 3 is going to give us 6. Now from here, if there's any like terms, you combine them. So let's look at our first term, x squared. Is there any other variable or number? Is there any other term that has an x squared in it? No. So let's just leave it as is. All right, next term, 3x. Is there any other term here that has an x? Yes, 2x. So we're going to combine 3x and 2x. So 3x plus 2x gives you 5x. And finally, this 6. Is there any other terms that is just a whole number with no variables? No, so we just leave it alone. We drop it down. So in this case, when we are working with variables in our binomials, we would leave the variables by themselves. So if you multiply that binomial, this would be our final answer because we don't know what x is. If they give us what x is, then we could go ahead and evaluate what it means. But in this case, we can just leave as is. So let's do one more problem. So let's make this a bit of a challenge, right? So let's think about doing 4x plus 2 times 2x plus 2y. Okay, so now we have an additional y, but our steps are still going to be the same. So let's just see what happens when we multiply out this binomial. So first outer, oops, I misspelled that. first, outer, inner, last. Okay, so first, so let's take our first term, so that would be 4x and 2x. So 4x times 2x would give us, well, 4 times 2 is 8, and then x times x is going to be x squared. So 8x squared. Done. All right, second step, we take our outer terms, which is going to be 4x and 2y. Okay, so let's multiply what we know first. So that 4 times 2 is going to give us 8 again. But now we need to multiply this x and y together. So they're not like terms, so we just have to leave them as is. We just write them right next to each other. So 8x squared plus 8xy. So our second step is done. Now our inner terms, right? So this will be this 2 and this 2x. So 2 times 2x is going to be 4x. And then finally our last term. So it'll be this 2 and this 2y. So 2 times 2y will be 4y. And as you can see, we don't have any like terms here. So we have this 8x squared, 8xy, plus 4x, plus 4y. And none of these terms have the same variable, right? So this x squared cannot combine with this xy because this y is attached to this x. Same thing for this 4x. This 4x cannot combine with this 8xy because this 4x only has an x. It does not have an xy. And it can't combine with x squared because we're adding them. So if we're adding them, they have to be raised to the same power. However, 4x is not 4x squared, so we cannot combine it with that. Same thing with 4y. 4y cannot combine with 8xy because it's missing an x. It would need that x in order to be combined since we're adding them. So this would be our final answer.